And now we come to the topic of optics, wherein we look at the concept of light, concepts of reflection and refraction of light, and then image formation using mirrors and lenses. Electromagnetic waves have been covered to a certain extent when we talked about temperature and heat, particularly thermal radiation, which is the heat transfer via the motion of electromagnetic waves. Electromagnetic waves is basically a traveling wave of electric field and magnetic fields coupled together and are perpendicular to each other. It has been shown that light is an electromagnetic wave. Therefore, as far as our course is concerned, the two are interchangeable, light and electromagnetic wave. Unlike mechanical waves, electromagnetic waves do not need a medium in order to propagate and exist. In vacuum, the speed of light is given by c, where c is equal to 3 times 10 to the 8th power meters per second. Light does not need a medium in order to travel, but it can travel through different media, and through different media, the light has different speeds, but in vacuum, the speed of light is constant at 3 times 10 to the 8th power meters per second. There are different spectra or types of light. You have long waves, radio waves, infrared, visible light, ultraviolet light, X-rays, and gamma rays. These are all electromagnetic waves. Light is a wave that travels in all directions from the source. As such, just like sound waves, the intensity of light is given by the following equation. Intensity I is equal to power of the source divided by the surface area upon which the light is spread out. I is equal to P over A. As such, light is also subject to the inverse square law. I1 is equal to I2 R2 squared divided by R1 squared. I1 is intensity at location 1. R1 is distance of location 1 from the source. I2 is intensity at location 2. And R2 is distance of location 2 from the source. When light is incident upon the interface or border between two media, for example, medium 1 and medium 2, the light will either bounce off the interface, you have reflection of light, or it will pass through the interface. You have refraction of light. And of course, you can have both things happening at the same time. That when light strikes an interface, part of it will bounce off and part of it will pass through the interface. First, let's look at reflection of light. You have medium 1, medium 2. You have the interface between the two media. You have light in medium 1 striking the interface. You have incident light. It has an angle theta 1 with respect to the normal line. It will bounce off, reflect off the interface with an angle of theta 2 with respect to the normal line. So you have your incident light and reflected light. Theta 1 is angle of incidence and theta 2 is angle of reflection. The law of reflection tells us that the two angles are equal. The angle of incidence and the angle of reflection have the same value. Theta 2 is equal to theta 1. Next, we have the law of refraction, also referred to as Snell's law. When light passes through the interface or the border between two media, again, you have medium 1 and medium 2, the angle with respect to the normal line changes. From theta 1, the angle becomes theta 2. Theta 1, angle of incidence. Theta 2, angle of refraction. And the change in the angle values is described by the following equation, the law of refraction. N2 sine theta 2 is equal to N1 sine theta 1, where N is index of refraction of the medium. It's property of the medium. It describes how the speed of light changes when you have a medium that is different from vacuum, that is not vacuum. N is basically the ratio between the speed of light in vacuum and the speed of light in the medium. N is equal to C over V. So again, N is property of the medium. So you have N1, index of refraction of medium 1, and N2, index of refraction of medium 2. Light has been shown or observed to be unaffected when light moves from one medium to another. So, light frequency in medium 1 is the same as light frequency in medium 2, and so on. What is affected is the wavelength of light. Thus, we can also describe index of refraction in terms of wavelength. N is equal to wavelength of light in vacuum divided by wavelength of light in the medium. N is equal to lambda C divided by lambda V. Now, here are some values of index of refraction that you should be familiar with, that you should memorize, or it's recommended that you memorize them. You have index of refraction of vacuum, 1. Index of refraction of air is approximately 1. So that means basically we can consider the speed of light in vacuum to be the speed of light in air. 3 times 10 to the 8th power meters per second. Again, 3 times 10 to the 8th power meters per second. And then you have the index of refraction of water, 1.33. Refraction of light is also referred to as transmission of light, transmission of the wave from one medium to another. Normally, both reflection and refraction of light happens. That is when light strikes the interface between two media, part of the light will bounce off and part of the light will pass through. Under certain conditions, light that should normally refract does not refract, only reflection happens. This is referred to as total internal reflection. And the conditions are as follows. The angle of incidence must be at the value referred to as critical angle. Theta C is equal to inverse sine of N2 divided by N1. And the other condition is that N1 must be greater than N2. When these two conditions are satisfied, total internal reflection happens. And that's it for now. In the next video, we'll cover image formation using mirrors.